Our last speaker is Kenny Andrews, who will talk about modeling access differences to reduce disparity in resource allocation.
Hello, everybody. I'm Kenya, and I'm so excited to be here to share my work with you. That my advisor, Mesrob Ohannessian, and our collaborator, Tanya Berger-Wolf, have been working on, which looks at how we can allocate fairly while considering and prioritizing vulnerable populations. So our world is broken up into different sections like countries, states, counties, census tracts. And there are people there that need resources. Sometimes those resources are life critical. So we want to make sure that we have a fair way of allocating those things to the people. Oftentimes, people decide to use a proportional allocation to the population size at these different locations. But there's a big problem with this. Everyone in these different locations have their own unique experiences and experience life sometimes in a way that makes them particularly vulnerable to when they lack a resource. So, how can we ensure that when we allocate, we take in consideration these vulnerabilities and these differences for people? Well, we first acknowledge a few things. One, that populations are stratified into disadvantaged and advantaged groups. Someone is disadvantaged if they are more vulnerable to something when they lack a resource. And simultaneously, they have obstacles that prevent them from freely acquiring a resource. What can we do about it? Well, first, we will look at resource disparity as a proxy for downstream impacts. And in order to quantify that, we will model access differences. And once we have those access differences, then we can make an access aware allocation. And we want to look at the gains that we get from doing such an allocation and validate our model. Okay, so let's first start with an example. Here we have the state of Illinois, and they have their own population and some resources. The availability of those resources is the number of resources over the population size. So the state of Illinois wants to allocate these resources to their different counties, like this one, where Chicago is. And so they'll get their own set of the resources and they have their own population. That's made up of disadvantaged and advantaged groups. We say that the fraction of disadvantage is beta. So, how can these two groups get resources? Well, let's first look at resource disparity, which is the difference in how the rate that advantaged people versus disadvantaged people acquire a resource. If there is no disparity in how these two groups acquire resources, then the disadvantaged group will acquire beta times n resources, and the advantaged group will acquire 1 minus beta times n resources. This will mean that our resource disparity is 0. But is this what actually happens? Well, let's look at our access model. Here we look at some arrivals as to when an advantage group and disadvantaged group will acquire resources. See, we have an advantaged person that has arrived to acquire their first resource, and another, and another. And then finally, we have our first arrival from a disadvantaged person. And this will go on throughout time until some until all of the resources are taken up, or a subpopulation will stop when they have all the resources that they need. This is called the saturation effect. So the rate at which disadvantaged people acquire these resources is beta, And the rate at which the advantaged people acquire the resources is 1 minus beta. This means that the disadvantage will acquire beta times n resources, and the advantage will acquire 1 minus beta times n resources. But we know that there are obstacles that prevent the disadvantaged group from acquiring resources freely. So we propose that we use eta as a slowdown rate to model this. And eta is going to be a number between 0 and 1. And if eta is 1, then that means that the disadvantaged can freely access a resource. There are no obstacles in their way. But if it's 0, then that means that they don't have any access to the resources and that there are too large of obstacles in their way. So we'll call eta the access gap. And the acquisition factor that says how these two groups will acquire, how the disadvantaged group acquires a resource is dependent on this access gap. We see here, oh, sorry. If we look at row in the paper, it's a little bit complex, but I do welcome you to look at the paper. Let's ignore the saturation effect. When we do this, then we can get something a little more simple, where we have the rate that the disadvantaged group acquires a resource over the overall rate of access. And we can see here that if eta is 1, that we get back beta. Now that we know our access model, we can have an allocation that is aware of this. So our goal here is to increase the resource flow to disadvantaged groups. Why? Because they need resources more than advantaged groups. With the lack of these resources, they are more likely to not recover the effects of not having them. So we want to be able to push more resources their way. And there are some governmental policies that prevent us from deviating too much from proportionality. So we will try to minimize resource disparity. You might think that we would want this number to be 0, but actually, because we want more resources to go towards the disadvantaged population, we welcome this number to be negative, while also trying to not deviate too much from proportionality and not giving out more resources than there are people. So let's apply this to a use case and see how does this help. We all remember the COVID-19 pandemic, as we are kind of still in it. So, so here, when vaccines were first being allocated, we know that they were being allocated proportionally, right? Well, when they're being allocated proportionally, we have the red line, which shows the vaccination rate disparity across different access rates. When we apply our model, we see a drop in the disparity between how people can get these resources, the vaccines. Now, how does this apply to something downstream? Let's look at the total expected hospitalizations. Here, the blue line shows the total expected hospitalizations for if we have a proportional allocation. But when we apply our model, we see a drop again in the expected hospitalization rates, which is great, right? And if you look at these two plots, they look very similar. That's because resource disparity has a linearly dependent relationship to expected hospitalization rates. So we can use it as a proxy for resource disparity. So does this always help? What about when there's different availabilities? Well, we see that it always helps for every access rate. And this is because we are redirecting more vaccines to the vulnerable community who needs it. So there are more opportunities for them to acquire those vaccines. You might think that with high availability, why do we need to even consider this? If there's high availability, everybody should be able to get it. But when we have that high availability, the advantage group can come in and take away all the vaccines before the disadvantaged group gets it. So we want to still have this allocation, put more vaccines where more disadvantaged people are to encourage them having a greater opportunity of receiving them. Okay. And also, we want to validate our model, but we don't have individual acquisition data for the subgroups. So instead, our model predicts the aggregate behavior of both groups and has and shows the negative um, sorry and shows the negative inverse relationship between access and disadvantage, such that if there is less the more disadvantaged you are, then the less access that you have. Now, we see that this works also on the state levels and on a global level when we're allocating to different countries. So some key takeaways from the talk are that when we can lower resource disparity to have better outcomes in the downstream effect. We saw with COVID-19 vaccines that we can lower hospitalization rates, even things like death rates. And in order to quantify this, we want to model access differences amongst the two groups. Once we have this model of access, then we can create an access aware allocation to push more resources toward the disadvantaged groups and reducing resource disparity. Also, we can validate our model. I would like to thank Amazon and the NSF for supporting this work. And that's all I have to share with you. Are there any questions?
Hello? Oh, yeah. So the first one, you may have mentioned this, but do you assume equal size for the advantage and disadvantage access group? And if not, does the size matter for the analysis?
Is your question, are the size of the groups the same?
Yeah.
So the size of disadvantaged and advantaged groups differ across each location. And the vulnerability for those groups is also different. There's high, medium, and low vulnerability within the disadvantaged group.
And so then in the analysis, do you treat the different vulnerability levels differently in the disadvantaged groups?
So our access gap, ADA, is actually robust enough, and it doesn't need to. We don't need to know it when we are creating this model.
Okay, thank you.
This allocation.
Other questions?
So I know that this would increase access to the disadvantaged group, but this also like increase like the resource utilization. Like for example, if you're having deciding where to like have like food banks, having it in a very wealthy neighborhood would probably be a waste. Is that something that you've looked into?
So is your question if we allocate too much that we will have some waste?
Or like, would this increase like resource utilization, like make it more efficient?
Mm, sorry, I'm not clear. We have more resources, and then sorry,
Or,
what's your question once more?
or like, could this like be more efficient use of resources
Oh,
if we did it this way?
Yes. Whenever we allocate more, we can't exactly tell somebody like go use the resources that you have, and especially like we as machine learning people are not motivating them by saying like by re-educating them to pick up a resource or anything like that. So we hope that the utilization will increase because the access barrier of locality is decreasing, right? So we are encouraging them to get it more by being closer to it. But we hope that, we hope that grassroots organizations will, do the work of saying, hey, encourage other people, educate them to get these resources. But we have a no waste constraint that also says like we don't allocate more resources than there are people to a particular location. So we hope that there will also be no waste in this. Does that answer your question? Okay.
Great. Thank you, everybody,
Thank
for
you.
your amazing